Assalamualaikum warahmatullahi wabarakatuh. Greetings, Mr. Dai and mechanical engineering class. So in this opportunity, I will present my final project about the optimization of a pressurized hydrogen storage case study. But before we start, it's very good to remember about the consciousness itself. Very well, in my opinion, I am my consciousness, or it can be a quote by Mr. Dai itself. For me, it's very good phrase to implement in our daily life. An example, after we waking up in the morning, we consciously rush to the campus to learn something new. While on campus, we also have to consciously pay attention to the lecturer. When doing our assignments, quizzes, or homework, we also have to be conscious and serious when we're doing it. Without realizing it, we actually always implementing the quote of I am my consciousness itself in our daily basis. So, in terms of numerical method lectures, we can correlate the theory of the consciousness with some expression of the x to the power of 2 minus 1 over x minus 1. So if we are conscious enough to solve that, we have to not to direct calculating it, but we must to canceling with each other first, so the result is not becoming zero. Therefore, consciousness is very relevant to this lecture, or in understanding in the significance of the numerical method. For me, I always believe nothing is achieved without obstacle and struggles. For the example, our knowledge limitation and the time limit or the time bound to make some assignment quizzes or anything else. However, but when we're conscious enough and widely open our eyes, nowadays access to the internet, academic journals, or the other sources is very easy to obtain. We can put much efforts on reading journals and learn new things outside the class to gaining out knowledge. When we start struggling, just remember and conscious that there is the creator who will always help us make things easier for us. So another effort that we can do is when we're having a quiz, that we're conscious enough to not cheating with our friends, or when the lecture, we have to be conscious to pay attention to the lecturer, and many things that we can correlate the consciousness in our daily life. But for me, it's one of many things that we can do, and we can put much effort to be conscious in our life. So next, we're going to discuss a little bit about the pressurized hydrogen storage. So pressurized hydrogen storage is a method of storing hydrogen gas by compressing it to high pressure inside the storage vessel or tanks. So in this case, or in this assignment, our goals is to finalize the design and optimizing the pressurized hydrogen storage, but with some specification with the gas being pressured at 8 bars and the volume is 1 liter. So the first step that we need to consider is the material selection itself. So, and we have the cost constraint within the maximum of 500,000 rupiah. So it is not much that we can do with 500,000 rupiah, but if we consider the material, and we can if we're optimizing the best material and the cheap material, but with the strength and with the good specification, we can improve the gas tank. So here the material that I choose is the 4130 steel, or commonly known as the alloy steel. So why did I pick this material because this material is commonly used in aerospace, automotive, and structural component. For the properties itself, the tensile strength is around 560 to 700 MPa, and the yield strength approximately 460 to 590 MPa. And then why again? The 4130 still is compatible with hydrogen gas, but it may require appropriate surface treatment or a coating still. Besides that, this material very good in strength and corrosion resistance compared to the standard carbon steels. So for the geometrical, I choose the cylindrical shape, since the geometric tank usually and commonly use the cylindrical tank. Why? Because when the geometry is cylindrical, it can maximize the use of available volume and allowing the efficient storage of the hydrogen itself. Moreover, the cylindrical is also provides a larger internal volume compared to the other shapes with the same external dimension. And then cylindrical tanks also distribute stress uniformly along the walls, resulting in a structural efficient design. So next, we need to optimize the surface area. How I do some iteration in the Python, or maybe you guys can try in another coding software. But in this case, I do some iteration within the nested loop method. The outer loop iterates over different radius values, while the inner loop iterates over different height values. The combination of nested loop allows for systematically considering various combination of radius and height for the cylindrical structure. So after we put this on Python, and then after we run this code, we can get the result, and the result we can have the dimension of the surface area of this cylindrical geometry. So what we got here is the radius is 5 centimeter, the height is 13 centimeter, and the surface area is 565.5 centimeter cubes. While here we have the specification with the volume of 1 liter, and here we also got the 1 liter approximately, or the 1021 centimeter cubes, or is it or it's the 100 millimeter, or it's 1 liter. And then we can search, or we have to find it hoop stress, while we can make this iteration on Python again. Since the specification is 8 bars on pressure, we can have this here P equal to the 8 bars. Okay. And then after we run, we already got the result, and we got the thickness from the result above. We can take the mean from 2 millimeter to 9.9 millimeter, which is around 6 millimeter of thickness. Therefore, we already got the specification of the tank. With the radius 5 centimeter, the height is 13 centimeter, and the thickness is 6 millimeter. So what the next point that we need to consider is about the cost budgeting. So to calculate the cost material and the manufacturing process, we have to know of course, the dimension and thickness, volume, surface area, height, and the radius, and the material itself. So based on my approximate and based on my research on the internet, while if we try to make some approximate where the cost of 1 kilogram per steel, or it's for 130 steel, we can assume it's about the 30,000 rupiah if we round up, and then the material cost is about 78,000 rupiah, or we can round to 80,000 rupiah. And meanwhile, we have to consider the manufacturing process, and we can approximate it about the 50,000 rupiah. So the total cost is the material cost plus the manufacturing cost. The total is about 128.590 rupiah. Or if we round, we can get the 130,000 of rupiah. So the estimated price is about 130,000 rupiah, but please note that the price may vary due to the price difference of or the certain specification of the steel. Also, there are some tools that not included in this calculation, like the port, pressure sensors, doom protector, polymer linen with high density specification, and so on. But overall, this design has not passed even far from the specific budget limit. So for the conclusion, the cylindrical shape is the most suitable geometry for hydrogen tank, since cylindrical shape itself, as well I mentioned before, it can very utilize its volume, and uniform its stress distribution, ease of fabrication, and so on. So in our calculation, we got the volume of the tank is around 1 liter, which exceeds the minimum required capacity of 1 liter itself. And then for the material, I choose the 4130 steel. Is commonly used as a material pressure vessel. Why? Because on its high strength, good weldability, and resistant to deformation under pressure. So that's all for today, and in this presentation. And thank you guys for watching.